In this video, we will continue our investigation of the strategy pattern and take a look at a couple of other ways that it is commonly implemented. When we look at our child class that we have here, we might consider that there is some violation of the principle of separation of concerns that we talked about earlier. Essentially, should a child class really be the one to decide what implementation of the player interface should be used based on the requested game? Should the child class even know about these different implementations of the player method, of the player interface rather? A nicer approach would be to use a separate class to contain this logic. We could refactor the game called method that we have here into a separate class, which effectively becomes a player factory. We might call this class player for game. So we could write something like player for game called game. Let's create this class and see what we can do with it. And I'm going to implement this method. And the way I'm going to implement this method is basically to duplicate what we have here, because it's effectively the same thing. I'm going to create a method called, and this will hide away all of the logic about which which player implementation we choose. Now let's go back here and we can safely delete this class, this method. So now our class becomes much simpler. We have the child with its main goPlay method. The goPlay method asks the player for game factory what player implementation it should use, and then calls the play method on it. And the play for game's job is to choose which implementation to provide. So the player for game is effectively a factory class. A factory class is a class that produces instances of another class. And that's exactly what we're doing here. This is actually quite a common variation of the strategy pattern, where we combine the strategy pattern with a factory class to hide away the logic that determines which implementation of a strategy could be used.